after we take the AP exam, we will do some work from Unit 4, which is not tested, but it's still stuff you should know. All right, so we're doing the sheet that's called practice, big letters at the top, and it starts off with the calculator part. So we're gonna have to be able to do a little bit of stuff on our calculator. So let's check that out and see if we can figure out what we're supposed to figure out. Find a relative max and a relative min. All right, let's graph it and see what we've got.
This is for tractor suppose.
Yep.
Oh, never mind.
Did you get something that looks like a classic cube shape? And you know the relative max would be the top of the hill, and the min would be the bottom of the valley. So let's find it. Second calc, I don't care which one you do first. But please do remember, what is our rounding? 1,000. If you are gonna round something off, it has to be at least to the 1,000. So, what point did you get? Oh, this says relative max at x equals. Oh, I did the minimum. Did anyone else do the minimum yet? I got 0.717 for my minimum. Okay. And now I have to do the maximum. I got negative 0.245 for my max. No?
Which one is it?
I got 1.27.
I got negative 245.
I don't know, let's figure that out though. Because, did you match on our minimum?
Yeah.
Okay, well then I know you got the right equation there, so I don't know what it's just. So your maximum happens when x is negative 0.245. If you're having a hard time with that, that's when you come into office hours. And, I mean, it'll take us 2 seconds to figure out what you're doing wrong, but you gotta be able to do that. You gotta be able to find that max and min. Okay, what else do we need to do? All right, now we're gonna graph another one, and we're gonna figure out where it changes from increasing to decreasing. Now, you guys, before we do this, just think about that for a minute. Increasing means the function is going up, right? And then decreasing means it's going down. So if we are changing from going up to going down, what are we looking for? Not a point of inflection. Are we looking for a maximum? The function increases, the function decreases. The point where that changes is a maximum. Number 2 is just asking the same question a different way. Find the maximum. Did you get a W looking thing? happening here? What is happening? The function is decreasing, and then it becomes,
Concave down.
okay, now wait, this isn't a conversation about concavity. This is a change of, or this is a question about, where is my paper? This is a question about the curve changes from increasing to decreasing. What's concavity? Rate of change, increasing and decreasing. That's not what's happening here. We're talking about the curve itself, y. Y is decreasing to here and then increasing. So that's going to be an answer to part B. We're going from decreasing to increasing. Now, what happens here at this point? We go from increasing to decreasing. So that's going to be an answer to point or part A. And then what happens here? We go from decreasing to increasing. So this is going to be another part B answer. Does that make sense to everybody? Okay, so this goes back to, you just got to read it so carefully. If we talked about the rate of change increasing or decreasing, then we'd be talking about concavity. But this is g of x. This is y. Going down or going up? All right, so have you found them yet? What have you got? Second. This one to be x equals negative 0.598. Does that sound about right?
Yeah, that's what I got.
And then, was this one positive 0.598?
Yeah.
Let's just be weird.
And then what was this one?
0.
Was that 0? Is that right? I didn't type it in.
My calculator's not giving me decreases.
We're looking at the x values.
Yeah.
What's it not giving you?
My maximum.
Okay, so you're gonna set a bound over here, a bound over here.
Right.
What's it saying?
1.77.
Okay, then what though?
And then y equals 7.89. I zoomed in.
No, see, that's important, guys, when the calculator says something, I don't know what it said, but then it has an E like this, that's scientific notation. This means 1.776 times 10 to the negative 6. Tell me about 10 to the negative 6.
Really small.
Really small. So that is your calculator's way of saying 0. That's 0. That's 0.00000. That's 0. Calculator's not a perfect machine. There's a little round off error in it. Sometimes the round off error catches up to it. But anytime that happens, you're to think of it as 0. Okay? Now, the point I want to emphasize here is the two problems we've done so far are basically the same problem. We're finding max and min, but they're worded differently. So you got to understand they mean the same thing. You're finding a maximum or a minimum. Okay, now we're going to put our calculator apart away. For number 3, you are to fill in either increasing or decreasing. So what do you think? The picture that I drew is increasing at a decreasing rate. It's increasing because it's going up. a decreasing rate because it's concave
Down.
down. Perfect. All right, work on number 4 for a second. It's gonna take a little bit of time, a little bit of work. You're trying to figure out if this guy could be concave down. I went ahead and just started finding differences. Average, I found rates of change. These are okay over here, this is good news, right? So the rate of change here would be negative 12 over 1, negative 12 over 1, negative 6 over 1, and 6 over 1. I literally want to see the rate of change, it's right there. Now what's happening to those numbers? Wait, are they increasing? Are they all increasing? Not all of them. Okay, so if we want to know if we're concave up or down on that interval, what has to be happening? They all got to be behaving the same way. And didn't it say concave down? That would be a big old fat no. It can't be concave down because these are all either staying the same or going up. And if you're concave down, your rate of change is decreasing. Yep.
But it can't be concave up either.
Can't be concave up either. Not on that whole interval, not from 1 to 5, no. Now, Alex, if we left that first one off, then we can say it. But look, here were my first differences, here were my second differences, and here are my third differences. What kind of polynomial do we have here? We have a cubic polynomial.
So, in my answer I said no, the rate of change is increasing. Would that be wrong?
It would be because it's not increasing on the whole interval.
So,
So a better answer would be, it's not decreasing. Because at the very beginning, it stayed the same,
Wait. Yeah.
not
And then I just
decreasing.
said
Kids, if you're gonna be concave down, what does that mean about your rate of change? It is decreasing? Here are your rates of change, right here. Are they decreasing? No, they are not. All that other stuff I did, but this would answer the question. These are not decreasing. All right, take a look at the picture now. I've drawn it, so we're okay. Well, first of all, do I have a relative maximum? I have how many relative maximums? 1. And it is where x is 3. Do I have any relative minimums? I do. Ignore my graph, that's supposed to go through that point. So one of them is at negative 3, and one of them is at 5, where x is negative 3 and x is 5. Everybody okay with that? Do I have an absolute maximum in this picture?
no.
No, because I have arrows. Do I have an absolute minimum? Yep, and it's where x is -3. On which interval or intervals are we increasing and concave up? So we're increasing and concave up. Where do you see that happening? From -3 to 0? And then from 1, 2, 3, 5 to infinity? Is everybody okay with that? Where is the rate of change negative and increasing? Okay, so wait a minute, let's pause for a second. Rate of change negative. What does that mean? Rate of change negative. It's going down, right? The slope is going down, the picture's going down. Where is the rate of change increasing? What does that mean? Concave up. So where are we going down and concave up? What do you think?
Negative infinity.
Negative infinity to -3.
3 to 5.
And from,
3 to 5.
I'm not sure we can say 3 to 5 because isn't part of that concave down? How about 4 to 5? Would that work? Got a point of inflection at about 4? Would you agree with that? Okay. What was that? That was F? Okay, 6, solve. Wait, did I do F already? Or did I just do,
Yeah,
I just did F? Yeah, okay. So now I'm ready for 6. What are we gonna do in terms of showing work for problem 6? We're gonna have a number line. Right? And we're gonna have dots, closed dots, marked on the number line at -2, 0, and 3. Does everyone agree with that? And then we're gonna pick a number in each of these intervals, and we're going to see if it yields a positive result greater than 0. All right, so you go, I'll go, we'll see if we match up here.
There's supposed to be a negative sign in front
Oh, thank you, Avery. Okay, so my answer's, everything's wrong. It's gonna be exactly the opposite of what I have. So, did you end up with just -2 to 0? Everything I did is now wrong. Thank you, Avery. that's right, all of these weeks, so it's 0, but I got it, yeah. So we'll just say, 4 x equals 3. We'll just have to say, yep, you're exactly right, because that guy right there is a solid dot. So when I do my number line and everything changes, I end up shading. These are all colored in. And I end up shading over this part, but that dot is still colored in. And we don't write a single point as an interval, so I'll just say x equals 3. Okay? Sorry about that. All right, number 7, find all the intervals where h of x is greater than 0. Don't make this hard. What does that mean? We're above the x-axis. So bigger than 0 would be negative infinity to negative 4. And then negative 4 to 1, I think, 1. No, because it's not or equal to 0. It skips over negative 4. Right, that would be an open dot.
Wait,
So it can't equal, it's what Annabelle was saying only backwards. These dots are all open, so none of them would be included.
if it was closed.
So did you get them all? Just those two? Negative infinity to negative 4, and then negative 4 to 1. That's it. All right, this is what we practiced last time. Write a possible equation for this stuff. A possible equation. So let's start with our factors. What will our factors be? X plus 1, okay, got that one. X, what'd you say? Minus 3, okay. And then X,
Was it not x minus 3 squared?
well, I'm not there yet. I'm just writing my factors first. I still need one
Minus
more factor.
plus 5.
Plus 5? Okay, so we got the factors written. Now we gotta look at the behavior at each factor, and somebody over here said, this one should be squared. How do we know that? Because it bounces there. Do I need to do anything with the other two? No, there's regular factors. Do I need really to put anything else into the problem? No, because it is up, which means it will be a positive. So leaving it blank implies a positive 1. So you really don't need anything. If it were upside down, you would have to make sure you put a negative out here, right? Everybody okay with that? All right, state the zeros, or find the zeros and state their multiplicity. X equals 0, multiplicity 2. X equals negative 2. And x equals 6, multiplicity 3.
I'll make a test or a quiz if we put multiplicity 1.
No.
You just put
You just put x equals negative 2. All right, now B, what is B gonna require you to do? Factor. So it looks like x equals negative 4 and x equals 4 with a multiplicity of 3. Would you agree with that? All right, you do C. You're going to have to factor C also. do C and see what you come up with. Potentially, I'm gonna have 5 zeros to this, right? How do I know? If I FOILed it all together, I would have x to the fifth. So potentially, there's gonna be 5 zeros. Well, there's gonna be 5 zeros, but some of them might be repeated. So what'd you come up with? X equals what?
5,
0,
0, negative 5,
negative 5,
negative 2, multiplicity.
negative 2 with multiplicity 2. How does that look to everybody? Does that look right? Easy peasy. All right, let's do a little matching in number 10. Match the function with the end behaviors. Go.
Wait, Miss Ford, this is on the homework. Was this supposed to be multiple? Like we matched a multiple and behavior?
Oh, yeah.
Oh, I just did it single. Can I go grab my homework?
No. Because remember, lots of polynomials are up on the left and up on the right. Yeah, so they're gonna have repeat multiplicities, yeah. Just do this, just do this.
Yeah, I didn't see it. I just did the one.
Okay, what's going through your head when you look at problem 1? You look at function h, this big ugly thing. What are you immediately checking? How many x's do I have?
3.
No, well, how many total do I have, including multiplicities?
8.
I have 8. 8 is even. Right?
Yeah.
8 is even. There's a negative coefficient in front of it, which means it's going to be down, down. So for letter H, these are both negative infinity. So that means A and B. Now, what about J? First thing you do is see it's x cubed and negative. So that means it starts up and ends down. So the negative side is up and the positive side is down. So that matches up with B B and C.
Wait, this is for,
Mm-hmm.
how would it not be like down, like one?
It's X cubed. I'm looking at number 2.
Yeah, wait, isn't it 6 x's total?
No, 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 we're talking about when you multiply them together.
Oh. Okay, that's right, I messed up.
Okay, so what's going on with L? L is an even, positive, so aren't they both up? So that will be C and D. And then M is odd, positive, so that's down up. So that one is A, is that an A and B? We talked about this last time, one of the times. Polynomial in behavior is always the infinities. Rational in behavior, when you have the denominator, something over something, that throws in the asymptotes, and that in behavior is something different. Polynomials will always be the infinities. All right, 11, find the zeros. You don't have to factor it. You know how to do it, it's easy. Hopefully, it's easy. Did you get -4 and plus or minus side root 6? How many times does question 11 cross the x-axis? Once. It can still have a squiggly in it, but it's gonna look like, positive, yeah, it's gonna look maybe something like this. It only crosses one place. Because the other two roots are imaginary. Circle the true statements. What's happening here? Which ones are true? The rate of, somebody said B of X is decreasing. Absolutely. It's going down. The rate of change is increasing. Yep, because it's concave up. Perfect. All right, let's work on 13 and 14. See what you can come up with for 13 and 14. first one right here. What did you come up with? What did you decide was the best statement to describe our situation? D. D is the best answer. Now let's talk about, well, first of all, nobody picked linear, I hope, right? Nobody picks linear because the rates of change are not the same. Okay? The first differences here, these are all the same size. So we can, it's okay to look at just the 18, 36, 54, and 72. Those are not the same. So it can't be linear. All right, throw that out. So that means it must be quadratic.
Very good.
So if I look at just the differences, I have 18, 36, 54, 72, then my differences are 18, 18, 18. So I could say it's quadratic because the second differences are the same, but that's not an option. I have to look at the rates of change. So the rate of change goes from 6 to 12 to 18 to 24. 6, 12, 18, 24. What is happening to the rate of change? It is going up by the same amount. It's not constant, it's going up by the same amount, which means it is linear. The rate of change is linear. What did you decide with 14? Now this is all about concavity, so I have to look at the rates of change. So here are my rates of change. 5 over 5, 4 over 5, negative 6 over 5, negative 9 over 5. What's happening to those numbers? They are all going down, and since they're going down, my rate of change is decreasing. What am I? Concave down. D, the graph of H could be concave down because the average rates of change are decreasing. 15, which is true. C, increasing at a decreasing rate. Increasing because it's going up, decreasing rate because it's concave down. Right? All right, here we go. F of x has a domain negative 8 to infinity. Where is its global maximum? Let's put the point there, so that would be at 2 comma 1, 2, 3, 4, 2 comma 4. Would you agree with that? Does it have a local minimum?
Negative 3, negative 5.
1, 2, 3, negative 3, negative 5? Does it have a relative maximum? Yeah, it actually has 2. One would be negative 8 comma 3, right? And one would be whatever that first thing was, 2 comma 4. Remember, relatives can be a global or absolute. Does it have an absolute minimum? Nope, because we've got an arrow going down. On what intervals is f of x greater than 0? Let's use numbers. So it would be the interval from negative 8 to negative 6. Is that right? Did I count right? And then from, I don't know, about 1.5 to negative 1.5 to 1, 2, 3, 4, 5, 6.
It's negative 0.5.
Negative 0.5. Negative 0.5, negative 1/2 to 6. those, by the way, tell me about brackets and parentheses for that. For E, for letter E, where it's positive, that would be -8 to 6, like this.
Yeah.
And then, what do you say, -1/2, 0.5 to, what was that, 1, 2, 3, 4, 5, 6?
What's in the bracket of 8?
Is it actually greater than 0 at -8? Yeah, it's not equal to 0, it's actually greater than 0 there. Does that make sense to you, Alex? Alright. Now, F is gonna be bracketed, where are we less than 0? That would be from 1, 2, 3, 4, 5, -6 to -0.5. And then from 6 to 3. Are there any points of inflection? And again, we can argue these, but let's just approximate it. Where do you think we might have a point of inflection? Point G, -60? And how can I tell? Because very intentionally, it looks like it's concave down and then becomes concave up. Are there any others? I could make a case for F. I could also make a case for C. Right, one of those is a point of inflection, and then I think that's it. I don't think there's any more. Would you agree with that? Where's it concave up? Between G and either F or C, depending on where you put your point of inflection. And is that it?
Is there a comma in between like -6 and -0.5?
Yes.
Would that make it okay?
Yeah, you're talking about intervals there. Yeah. Where's it concave down? Clearly from A to G, whatever those points are. And then either from F to infinity or C to infinity, depending on which of those points you picked as your point of inflection. Right? Where are we increasing? We're talking about the function now. Where is the function increasing? From B to D. B to D. Where is it decreasing? A to B and D to infinity. Decreasing and concave up, G to B. Decreasing and concave down, A to G. And actually D to infinity, wouldn't it be? Alright, we'll work on that last page and review one more time next time, and then it'll be quiz day. Look over those homework papers I turned back, guys.